So as I said, that you want to have a single outcome variable to know if your treatment has been successful or not. In this case, this is data which is measured the values before and after of the systolic and diastolic blood pressure, and then you can work out their differences. Now, the way you want to look and think about this set of data, I can summarize the before blood pressures. So we can do that. Let's summarize the before blood pressure. Both systolic and diastolic before. There's no factors here, so that makes this analysis quite simple. Let's get rid of that. I'll put on the histograms to have a look at it. Press OK. Now, this is showing you how much variation there is between individuals. So the mean value is 177, and it can go anywhere between 165, 166 and 188 in its confidence intervals. Is it normally distributed? It's got a bit of skew, but not a lot. The other one, the box plot looks fine. The histogram looks murky still. You've only got n equals 15. It's never going to look fantastic in this histogram when you've got n equals 15. Right, so let's assume it's normally distributed. So it goes, and you've got a standard error of 5.3, and on the other one you've got 112, and it goes between 107 and 118. So that's reasonably wide confidence intervals. You've got a change of about 11 units in one and 12 units in, no, 22 units in the other. That's better. So there's quite a lot of variation between individuals. Now, if you go back to your data, remembering how much those, so 12 a change of 12 or a change of 22. So here I've got the differences. So if I look at the difference, so the mean, the width of the confidence intervals is 22 units. But if I look at the difference between before and after of any individual, they're of the same sort of size or smaller than that 22 units. I mean, some of them are a bit bigger, but most of them are around the size of the variation amongst the participants. And the same is true for the diastolic, where there was a difference of 11. So in some cases, you wouldn't detect any difference whatsoever. If I was comparing the average before and the average after, it's very difficult for you to see any kind of difference if you don't compare it on an individual level, because there's so much variation within the population itself. So when I'm presenting this study, I want to say n equals 15, that's how many participants are. The average blood pressure before is this, and the confidence interval goes from one number to the other number, the systolic and diastolic. So that's what I want to report as my summaries before I start. I also want to report the summaries of the averages for after. So let's do that as well. Oops. So now if I go back to these, so after it's 146 to 169, and after it's 96 to 110. Now, looking at the, let's look at the systolic one, because that's the one that has the biggest number of changes. So if I look here, the confidence interval goes from before I did the treatment, 166 to 188. Afterwards, it goes from 147 to 169. The two confidence intervals from before and after overlap with each other, but only slightly. So this is suggestive that your treatment is working. But because they overlap at all, it means I'm fairly unlikely, when you go on to do the later thing, which is called hypothesis testing, to see that there's a big difference between the two of them. For the diastolic, it goes from 107 to 118, being its confidence interval, to 96 to 110. Again, there's overlap of the two confidence intervals. It's not a big overlap, but it's suggestive that your treatment's working, but it's not very strong evidence that your treatment's working. However, if I go back to my data, what I've done extra to that is calculated differences. And I've calculated them for systolic and diastolic. Now what I can do is calculate the confidence intervals for the differences. So let's get rid of these. Now, if my treatment is not working, then the average difference, the confidence interval for the difference, should contain 0, meaning that the treatment hasn't worked. The treatment and control group behave in the same way. So therefore, if I put in the differences and calculate their confidence intervals, I know that my treatment is working if these confidence intervals do not contain 0. So I press OK. So the confidence interval from this one is from -24 to -14. That definitely doesn't contain 0. And the other one is -14 to -4. And that definitely doesn't contain 0 either. So by looking at the confidence intervals of the differences, I can tell that my drug is working. I can also look at its normality. So confidence intervals are very important and very powerful. They can prevent you having to do the next step, which is formal hypothesis testing. So if I just reported in my summary table of this experiment the confidence intervals for the differences, then this would show that there's a significant difference because of the drug. Even though for some individuals there's actually a positive change in diastolic. If I look at the data, yeah, there's a +4 there and a +2 there, but it still tells you that there is that the drug's being effective.